So we have did this yesterday. So I did all the different classes. Cat implements collection, so you see all the methods of the collection interface. Hippo implements list, you can see all the methods of the list interface. Ostrich implements set, and you can see all the methods of the set interface. Falcon implemented queue, you can see all the methods of the queue interface. It also takes one generic, so you can put the generic in or not, it's up to yourself. Rhino implements the map interface. Now the map interface has got two types in it. Now the map interface does not implement the collection interface. Okay, it does not implement the collection interface. It's the only object. It's the only list we're going to be using that does not implement the collection. The reason it doesn't is because it's got two values. Okay, so every object inside our map has got two values: the object itself and a uniquely identifying value. Okay, so a PPS number and a person, a car registration and a car. Okay, so maps linking closely with databases. Databases are all about something called having a primary key and a value. Okay, so we will be covering maps, but not for probably sometime next week. Okay, so we're going to start off with static void ex1. Okay, so on our files, I'm going to go to main, and I go examples.ex1. Close off all these. Let's open. Now, so good morning, Lisa. Now, so if we just look at the cat class, the cat class implements collection. Okay, now the interface itself uses a generic type. Actually, it usually says E. Okay, interface collection E. Now, I didn't use a generic type in it, so all the methods are going to be an object. Does everyone understand that? Yes? So coming back to generics, if you don't supply it with the type, it's going to say they're all objects. All right. It's the exact same thing with lists. So if you do it in a list, you don't supply it with a type, it's going to be a list of objects. You do a set, you don't provide it with a type, it's going to be a set of objects. You do a queue, you don't provide it with the type, it's going to be a queue of objects. You do a hash map with no values or with no generics. That's a whole different ballgame. All right, which I'm not going to get into yet. All right, so lists, queues, and sets. If you do not provide it with a type, the type is automatically going to be an object. Yes? So you're going to have a set of objects, you're going to have a list of objects, you're going to have a queue of objects. Maps are slightly different. So is everyone with me so far? Yes? So when we created the cat, we didn't put in a generic. Okay? So all of the methods here are going to take objects. Okay? So we can see here object. Now some of them will take collections, but that's neither here nor there. Okay, so add, if we provide it with the type, it would put in, let's say it was cats. You'd have a cat arg0. If the generic type was string, then that would be a string. If the generic type was a string builder, then that would be a string builder. If it was a thread, then that would be a thread. Okay, so I haven't provided it with the generic type. So going to go here. So this is just a kind of a little bit of revision of generics again before we get into it. So if I go cat tables equal to new cat or cat. So cat class did not specify a generic in the class declaration. Okay, so you don't have to provide one there. In actual fact, you'll get an error if you do. Right, so you'll get an error there if you do. Okay. Now, cat class did not specify generic in the class declaration. Now, cat class implements collection. What I said? Yeah. Cat class implements collection. So, methods in this class will take a object. Okay. For instance, in the cat class, we can see add. Okay, that's the same add method that you have when you're adding something to an array list. That's what it is. So when you provide it with the generic type, let's say dog, it'll be add dog arg0. If you're adding it to a list of animals, it'll be add animal arg0. Okay? So the methods in this class will take an object. Don't have a choice. Okay? You can create a cat with a generic type. As a generic type was not included in the class declaration.
John Shevlin, contact extension 257. John Shevlin, contact extension 257.
Now,
thank you.
So, the hippo class. We have a look at the hippo class. Now, the hippo class does give us a generic. Okay, so T will become whatever we say hippo is created with. All right, so if I go back to here, if I create a hippo and I create it with the string and I call it Harry is equal to new hippo. And I import it. Now, so hippo did specify a generic, which is then passed to the collection interface, and that becomes the type used in methods of the collection interface, i.e. add. Okay, so we can only add strings to this hippo, right? So if I go Harry dot add, okay, we can see that the method is, the add method only takes a string and nothing else. Okay, if I try to add anything else to it, so I'm going to add a string to it. Hello. Dot add another one, banana. Now if I trim to add anything else, dot add, let's say cat, we get an error. Okay, why? Because we said the generic type is a string. So what do the methods of the collection interface use? They use a string. Okay, so add, for instance, type T becomes string. I'm only showing you this because this is the way the collection interface works, this is the way the list interface works, this is the way the set interface works, this is the way the queue interface works. You're provided with a type, and then that type is going to be used inside here. So add is going to be, that's going to be a string, that's going to be a string, that's going to be a string, that's going to be a string. Now that's an object, that's a different thing. Where else is there? That's going to be a string, that's going to be a string, that's going to be a string. So wherever there's a T, it's going to be type string. Yes? That's why when you're creating a list or an array list, if you're provided with a type, you're creating methods then that can only take that type. Okay? So this hippo can only take strings in its add method. Okay? But this will not compile. Okay? Now, if you don't specify a generic, hippo, Helen is equal to new hippo. Now, that means that the generic type is an object. Okay, if you don't specify a type, then the generic is a object, and we can add any object to this hippo. Okay, so the add method for the hippo again, that becomes object. If you don't supply a type, it's given a default type of object. So you can add anything to this. So you can add strings. You can add objects, other objects. So I'm going to add okay, even an array list. So adding a string, adding an animal, adding an array list. Okay, so that's why generics are important when it comes to lists, because they're specifying what can go in a list, what can go in a set, what can go in a queue. Okay, everyone with me so far? Yes? Okay, so we're just going to do some general methods of the various types. Okay, so first one, which you're all familiar with, is add. Okay, so I'm going to create a list of strings. So I go list. So this is a list reference. Now, Java UTL, Java AWT, just to explain, AWT is to do with GUIs. It's to do with an old style of GUIs. All right, we want to use. So there is different classes of the same name. Now, if you want to use both of those classes, you can't actually import the two of them. What you actually have to do in that situation is you would import one of them, and then you'd use the fully qualified name for the other one. All right. So you'd have to go java.awt.list my list is equal to new list. All right. So if you're using two classes with the same name, you can import one of them and if you use a fully qualified name for the other one. The fully qualified name is the address or where it's residing in what library. But I'm not using the AWT one. It's the UTL one. All right. So there we have a list reference to an array list interface. Now that means now if I just have a look at the array list class here, class array list takes generic of type E. So whatever type you pass into it, that becomes the type that the array list can take. Now I made a slight mistake. Array list does have methods of something called random access, which I don't know anything about, iterable, which we'll be covering today, clonable, that allows us to have a method called clone, which allows us to create shallow copies, and serializable. Serializable is a way to zip up your classes. Okay, so you can have one object and it can be saved as a zipped file. Okay, basically a jar file. All right. Serializable is a very handy way for transporting. You can create your application. You can create your application as a serializable. You zip it off. You send it off to someone else, and it'll run perfectly on their machine. Okay. Now, so when we create a list reference to an array list object, it doesn't have access to serializable. It doesn't have access to clonable. It doesn't have access to iterable. It does have access to collection because a list is a sub interface of collection. Okay. Everyone with me so far? Yeah. Okay. So I create a list reference to an array list objects. Okay. Now I am going to add to the list, so it's very simple. All you're doing, so this is an array list of strings. So this is an array list strings. So we can only add strings to it. So I go str list.add. I'm going to go 1 str list.add. I'm going to go apple str list.add. I'm going to go sheep. So now we have an array list of strings. Now, so you can also add a particular index position. So in here, can also add at a particular index position. So if we go, first of all, print off str list. Oops, the wrong main. Right. So we've got one apple sheep. So we want to put in an orange at position 1. Okay, so we can go str list.add. I'm going to add it at position 1. So that will shove apple into position 2. Do you understand that? Okay, so I'm going to shove in an orange at position 1. Now, it doesn't replace apple. What it does is it puts orange between 1 and apple. Yeah? Okay. So I'm going to print that off. There it is. 1 orange apple sheep. Okay. So I'll just put this in here. Puts in orange between 1 and apple. Now, and remember, it's array indexing. Okay. Remember, it's array numbering. So start at 0. Now, so we're going to create a hash set. Okay, this is just a general introduction to the various different types. So this is introduction to hash set. To set. Okay, so I'm going to create a set reference. I'm going to call it ct str set, and I'm going to import this, import set java.utl, and it's going to be equal to new hash set. Now, so I'll import that. Now, hash set does not allow duplicates. Okay, so a list does allow duplicates. Okay, so if I go str list dot add orange, it will be added to the list. Okay, so a list allows duplicates. A hash set does not allow duplicates. Okay, so hash set implements the set interface. Now it implements a couple of other things as well, but all we're concerned about here is that it implements the set interface. Okay, and when it's a set does not allow duplicates. So to prove that it doesn't allow duplicates, now the same method, it is the same method add. Okay, so I'm going to go str set. Now I have it in a print statement. That add. I'm going to add the word orange. Okay. Next one, I'm going to put it in print statement as well. I'm going to try add an orange a second time. Okay. And I'm going to add in an apple. Okay. Bring up the old pin. Now, what happens here is now str set.add. Now, .add returns true or false. Okay, so the .add method returns true or false. Now, it doesn't really make a difference when you're adding a list. It's going to be added to the list anyway. When it comes to sets, right? So that will return true. So if something is inserted, correct? If it's inserted into the set, it'll return true. If it's not inserted into the set, it'll return false. Okay, so it'll add the orange, true. Try to add a second orange, it'll say false. Add an apple, it'll return true. Now, to prove that it is what I say it is, you can print it out the exact same way you print out an array list. We can see true, false, true. It inserted an orange and an apple. Okay, it did not insert the second orange. Yes, so it doesn't allow duplicates. Now, it doesn't allow duplicates. Will that be imported, yes or no? Yeah, it will, because it's capital O. Remember, Java is case sensitive. Okay, so you have orange, orange, apple, orange. Okay, now How does it determine? So it's fine for strings, no problem. For numbers, now that's going, if you insert a number into a list of integers, it's the wrapper number you put into it. That's easy as well, okay? Now, if you're using some of your own objects, I'm not going to cover it quite yet, it, how it determines if some two objects are the same, it uses the equals method, okay? So we are going to be inserting dogs into a hash set of dogs, and we're going to have an overridden equals method. So if, now you need to be careful with the equals method in a hash set, because here's a question for you. Normally I'm going to do an equals method. So let's say a dog has an age, and a name, and a weight. Dog 1 has an age of 1, he's a name of Spot, and he's a weight of 2.5. Dog 2 also has an age of 1, also has a name of Spot, also has a weight of 2.5. Now, so if we have the equals method, now they are two different dogs. Yes, do we all understand that? Yeah, they're two different dogs and they've got the same variables. You have two people with the same name and the same age. All right. Here you have two dogs, same age, same name, same weight. All right. Now, if you have your equals method done the wrong way for a hash set, it'll only put in one of those dogs. If you have the equals method to say that if they have the same age, name, and weight, it's going to return true, then it won't put in two dogs that happen to have the same age, the same name, the same weight. And you might want to put them in the list. So that's what I mean. You need to be careful with your equals method. All right. So how would you get around that? How you get around that is you give a unique ID to each dog. Okay. So this will be ID 2. This will be ID 3. If you give a unique ID to each dog, then that problem doesn't arise. Yes. Okay. Yeah. Okay. We're not going to come to that yet, though. Right? This is just an introduction. Now, hash sets do allow. Right. It does allow you to add null. Right? But here's the thing. It only allows you to add one null. Why? Why does it only allow you to add one null? Exactly. Okay. It's not because it doesn't. It's not because of the null itself. Is that it doesn't allow duplicates. Okay. So this one will be. So add returns true if it's inserted. Add returns a boolean. True if inserted. False if not. So this will return false. This will return true. This will return true. This will return true. This will return false. Can't have duplicates, even duplicate null. And to print them all out, you just go system.out println str set. Yeah. Say that again now, Priya. Yeah. Where's orange null? What do you mean if I put the this here? No, that'll print out true. Oh yeah, here. Yeah. The printout. Yeah, right. Oh fuck. I didn't look at that actually. Let me just see now. Ardent. Yeah, because here's the thing. Sets don't necessarily display the way something was input. Okay, right? Doesn't necessarily display the way they were input. Okay, you're not guaranteed that's going to be your output, right? Because you have to do something called comparable, or you send a comparator to it. Okay, so sets you're not guaranteed the layout. That's why. Okay. Yep. 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 Doesn't matter. It's null. No, it won't. So if I come along here, I'll take the first time, right? So I'll create string mystr is equal to null. Yeah. Okay. So animal, null animal equal to null. Now, if you try to put in null animal here, it won't work because it depends on the reference. See that? Even though it is null, this can only take references of type string. Doesn't matter if it's null. Okay, so I'll put that down here. Okay, so I put this at the very end. Yes, can have duplicate nulls. I'll just put in this one here. This is false. Right, so this one here. So even though this object is null, you can't add it to this set as the type is string, so it can only take strings. It can only take something of reference string. So the object really doesn't determine whether it can be taken or not. What matters is the reference. All right, and it's an animal reference. All right, so this will not compile. No, nothing to do with that at all. Okay. Now, if you had a null string as well, by the way, so let's say string down here, string null str is equal to null. If I try to import that, if I put it in str set.add null str, that won't go in either because it's null. Okay, can't have two nulls in a set. All right, so this will not be input. Now it will attempt to put it in. Okay, so you're not getting an error because it's a string, right? So what determines whether it'll compile or not is the reference. Okay, what will determine whether it's inputted into the set or not will be the actual value of it. Now we already have null in it. Okay, so this will return false as we already have null in this set. Okay, now We will be coming back to sets probably this evening. All right. So, and they print off the exact same way. Now you can't guarantee the order with sets. All right. Can't guarantee the orders at them. So we got orange, null, apple, orange. Yeah. Okay. Now, so just going through a couple of methods of it. The next one is remove. So we have our list, which has got, have a look at it, one orange, apple, sheep, orange. Okay. So I'm going to remove the first instance of orange from str list. So if I go str list dot remove orange, what does this do? This removes the first instance of, removes first instance of orange, lowercase orange, in str list. To prove that it's gone, str list dot print it off. There. Our first orange was after one, now gone. Okay. Now you can also use remove on a hash set. Okay. So I'm going to go str set dot remove. I'm going to remove null. All right. So and then I print off str set. There it is. Null is gone from it. Okay. Now, so this will remove. So sets and lists operates much the same way. Everyone with me so far? Yes. Okay. Now, if I want to remove something from a set, so I want to remove it from, I want to remove, so str list now contains one apple, sheep, and orange. I want to remove the item on the position, index position 3, which is the second orange. So can remove from a particular position. So I go str remove. I'm going to remove it at the index position. So we have one apple, sheep, orange. So I'm going to remove it, the second orange, which is at index position 3. Okay, this will remove the second orange. Second orange is gone. Okay. Now, if you try to remove something that's not there, so let's see str list dot remove pineapple. Now, sorry, I'll just do that again. I'll push it in a print statement. Now, right, so if I remove something, So if remove an object, okay, now you'll see that remove object O, it returns a Boolean. So if it finds something in your list and it removes it, it's going to return the word true. If it looks in the list and it's not there, you can't remove something that's not there, it's going to return false. Yes? So I'm going to go remove pineapple. So remove looks in our list for pineapple. There is no pineapple in our list. It contains one apple and sheep. So that's going to return false. All right. So remove returns true, returns a Boolean. Okay. True if the object is found and removed. Now, there is circumstances where it can find it and it can't remove it. Okay. If it's an immutable list, for instance. If it's an immutable list, it will be able to find it, but it can't remove it. Do you understand that? Yes? Okay. So if it's an immutable list, so it can find it, but it can't remove it. So that would also return false. Okay. Remove returns a Boolean. True if the object is found and removed. False if not. So it has to be both found and removed. If it's just found, it's going to return false. Okay? So str remove pineapple is going to be false. Now, you can, but as I said, you're not guaranteed that you know the right index position. Now I haven't fully revised the sets yet, so what I said, you can't guarantee the position. Don't take that as gospel quite yet. Okay. Um, there there is something to do with nulls and sets which you can't remember. Okay. So yes, you can move a particular position. Right. Now, with sets, I don't think you can guarantee positions. I need to look it up myself. Okay, so I'm not 100% sure on that. All right. So, but I will come back to that. We'll come on to them. Right now, if you try to remove from a non, so str list only has 3 items in it, so it only goes 0, 1, 2. So if you try to remove from a index position that does not exist, you will get index out of bounds exception. So if you attempt to remove an object that's not there, it'll compile and return the word false. If you try to remove an index position that's not there, you're going to get an index out of bounds position. So str list only has 3 objects in it, so it only goes as far as 2. So if I do this, str list dot remove index position 12, get index out of bounds exception. Okay, so generates index out of bounds exception. Now, so these are only all the methods that some important ones. Another one is empty and size. Now, with an array, it's length. and also length is a property. All right, property. How do I know it's a property? So let's say I have an array called my array. That's my array dot length. It's not a method. Okay, whereas you have a list dot size is a method. You have a set dot size. All right, so we want to get the size of our list. Simple, you go str list dot size, and Jesus, str set is str set dot size. Okay, size of str list is 3, size of str set is 3. Yeah, nothing too difficult there at all. All right, and if you want to check if an array or a set is empty, there's a method. So is strlist empty? We would go strlist dot is empty. That will be false. And is str set empty? We go str set dot is empty. Okay. Now, if you have an empty array list, just to show you, list integer my list. Now, that's just a reference. Okay. So you can't check if that's empty. Try to check is that empty, you're going to get a null pointer exception. Does everyone understand that? Because it doesn't have an object. So if I go my list dot is empty, it doesn't compile. All right, now it's not even null because it's a local variable. A local variable isn't given any default values. So we want to create an empty list. So new array list. So then I ask the question, is my list empty? I go my list dot empty. It's going to be true. Okay, it's not asking if it's a null list. Okay, you can have something like this. All right, now that's going to generate a null pointer exception. Anytime you're trying to call a method on a null object, you're going to get a null pointer exception. Now there is an exception to that rule. Is there any circumstance where a null object can call a method? It's a static. A null object can call static methods because you don't have to have an instance of a class to call a static method. Okay, so array list, funky dory, works out perfectly. Okay, now next method to cover. Now I think we've covered most of these in Java 1 and there's no harm in covering them again. Clear. Now clear does exactly as it says in the 10. So this deletes all elements in a collection. So I create a list of integers, and I call it numList equal to new array list. I'm get numList dot add all dot add all arrays dot as list, and I put in 23, 45, 66, 888, 999, 1000 or 10,000. Okay, so that list that's what it looks like there. And then if I go num list dot clear, and then I print out num list, you can see now it's empty. Yes? Any questions on that? All clear does is just clears out your list. Now we can also clear out sets. So str set dot clear. Str set is now empty as well. Yes? Okay. Just give me a second. I'm gonna just go to here. So you can also use arrays as list with a set. Okay, so str set add all arrays as list. So arrays as list takes a list. So add orange, apple, banana, apple, pineapple. So at the end of that, we should have orange, banana, apple, pineapple. Okay, so sets, what they're for, if you want unique values, that's what sets are for. Okay, but you have to be careful with sets. All right, as I've said already, if you have twins, right, if you don't have your equals method set up the right way, or if you don't have your objects set up the right way, it won't put in twins, it'll only put in one of them. Okay, and are twins two different people? Yes or no? Yes. So you'd want them in a set. So what you would do in that situation, you have two things you can do. You can change your equals method, or you can give each twin a unique identifier. All right, and you incorporate that into your equals method. So if every twin is going to have a unique identifier, then every twin is going to be unique. Yeah? Yep. Yep. Right. So you can't write now. So do I do that yet? Let me just see. Right. I'll do it later, but I'll explain it briefly now. Add all takes anything that implements the collection interface. Okay, so that can take a list, that can take a set, that can take a queue. It can take a hash map. Okay. Now arrays as list, that is an array. Okay. But as arrays as list returns a list. So arrays as list, it takes an array and it returns a list. Okay, so that is a list which does implement the collection interface. So add all only takes objects that implement the collection interface, list, sets, queues. Does not take hash maps, does not take arrays. Okay, so right. So yeah, yeah, no, no, because num list is an integers. Okay, so you can only add a collection of strings. Okay, so can only add collections of strings, which is this sets queues. Okay, now so right, just before we go any further, I want you to go to the dog class, please. Now, and the animal class. So I'm going to go static int count is equal to 0. This is the animal class. I'm going to go int age. I'm going to go string name. I'm going to have a blank constructor because I've already created animal objects that usage. I'm going to go count plus plus inside there. I'm going to create another constructor. Animal int age string name. This dot age is equal to age. This dot name is equal to name. And count plus plus. And I'm going to have a toString method inside it as well at override public string string. Return name is age is correct. Now I'm going to go to the dog class. So class dog. Now dog is going to have an age and a name and an ID. Everyone with me so far? Yes? Yeah. So I go dog string name int age, and I just got super name. Oops, sorry. Class dog extends animal. So super name and age. It's age, and by the way, it has to be public. This has to be public as well. So dog, its age and name. Now, that means that this dog is going to have an age and a name. It's also going to have an ID. Okay, where does it get its ID from? It gets its ID from here. Okay, starts off at 0. When you create a dog, it calls a superclass constructor, it calls this constructor, and it increments the counter by 1. Actually, I haven't done in here. I should say ID is equal to count. Int ID, and then we have ID is equal to count. ID is equal to count. Now, so we have an animal class, and each of the animals has a unique identifier. Okay, how do you know it's going to be unique? Because every time we call a constructor in the animal class, it's going to increment counter by 1. So our first animal is going to be ID of 1. Our second animal is going to have an ID of 2. All right. So I create one dog. It calls a superclass constructor that takes an age and a name. It increments the counter by 1. So it has an age, it has a name, and it has an ID of 1. I create a second dog. It has an age, it has a name, it has a ID of 2, and so on. Yes? So we can see what we're doing there is that every dog is going to have a unique ID. Yes? Okay. Right. So I'm going to go source, generate hash code and equals. Christ. I created inside here as well. Okay. All right. So I'm gonna go source, generate hash code and equals, age, ID, and name, generate. Okay, I don't care. So if this, right, now, the way I have, we'll ignore the animal class for now, okay? But the way I have it constructed, yeah, hold on a minute. Well, well, no, yeah, I'll take that out. Okay, I'll take that out. And I go this dot name is equal to name. This dot age is equal to age. Okay, so this refers to this guy. This refers to that lad. This refers to that guy. That refers to that guy. Okay, we'll ignore animal for now. All right. The only reason I did this here, I now remember, is because we're going to be creating lists of animals. We're going to be creating sets of animals. We're going to be creating hash maps of animals. And the hash maps of animals is going to be able to take a dog or an animal. All right. However, here. So here we have dogs. Now, every dog is going to have a unique identifier. All right. The unique identifier is going to have is this guy, ID. Every time we create a dog, it's going to increment this counter. Okay, so the first dog will have an ID of 1. The second dog will have an ID of 2. The third dog will have an ID of 3. Now if we go down here to the equals method, if the ID is the same, okay, it means they're the same dog. So if the ID is not the same as the other dog, it's going to return false. So they can have the same age and the same name, but if they have a different ID, then it's going to return false. You understand that? Now, we could change that. If we don't want twins in it, then the simplest thing to do there is take out the ID, right? If we don't want twin dogs in it, we take the ID out of the equals method, all right? We just take that out. That's the simplest way to do it. But here we are going to allow twin dogs. So I'm going to go back here to examples. Yep. Yep. Yeah. Yeah, but you see, that's a different static in count. This is the count for animal, or this is the count for dog. That's the count for animal. I'll call it a different name. No, 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 because it's a good idea to call it a different name. Animal count. No. Okay, so animal count. All right, so we have here public class dog extends animal int age. Now, as we're going along, by the way, we're going to be changing these classes as well. All right. Now we have to be careful when we're changing that we don't break our previous code. So we need to consider that as well. All right. So if public class dog extends animal, the extends an animal part is important here. All right. What is important is that it's got its own age, it's got its own name, it's got a static variable called count, it's got an ID. Okay. Now count plus plus ID is equal to count. So the first dog is going to have an ID of 1. The second dog is going to have an ID of 2, and so on and so forth. Now I'll ignore the hash code for now. If they're the same object, return true. If the object you're comparing with is not a dog, it's going to return false. At that situation, then the object we're comparing with, we know it's a dog, so the object we're comparing with it, we're going to cast it to be of type dog. Because if we don't cast it to be of type dog, what we have is an object reference to a dog object. We don't have access to the age, the ID, and the name of the dog. Okay, so if the age of the dog that's calling the method is not the same as the other dog, return false. If the ID of the dog is calling the method is not the same as the other dog, return false. In actual fact, you could make this a lot easier. You just have that line, that one, and that one, and that one. All we then need to check is the ID. Okay, we don't need to check the name. We don't need to check the age. We don't need to check anything else because every dog has a unique ID. Okay, if they're not the same ID, then they're different dogs. Do you understand that? Okay, but I'm going to leave it in. Okay, so now that's the way this equals is constructed. We may determine that we don't want twins. Two dogs that have the same name and the same age. They're twins. We could determine we don't want twins in our database. So then are in our set. Okay, because this is about sets. Equals is all about sets. All right. So if it returns true, it's not going to be put into the set. If it returns false, then it is going to be put into the set. I'll show you what I mean. So I'm going to create a set of dogs. call it dog set is equal to new, what did I say? What set am I using? Hash set. Okay, so import that, import dog. Now, I am going to create dog spot is equal to new dog, give him an age, or sorry, dog1. Is equal to new dog. It's going to have an age of 2 and a name of Spot. Spot is a very common name for a dog. Now, why isn't that working? It's the other way around, is it? Yep, it is too. So it's Spot. Right, so the constructor is public. Right, dog1 is equal to new dog Spot1. Dog2 is equal to new dog Spot and 1. Dog3 is equal to new dog Rex and 2. And we're going to say dog4 is equal to dog1. Okay, so we're going to attempt to add all of these dogs. Now, that is an individual dog. That is an individual dog. That is an individual dog. Okay, so them are 3 dogs. Now, this guy here, dog4 and dog1 are the same dog. Yes? So we've only got 3 dogs. Now, so it should put in dog1. It should put in dog2. It should put in dog3. But it won't put in dog4. Because our equals method says that if they're the same dog, or sorry, if they have the same ID, we're going to say they're equals, so dog4 won't be inserted. Okay, so I am going to go dog set dot add all. I go arrays as list. So we're going to try and add dog1, dog2, 3, dog4. Then we're going to print out all of the dogs. Bollocks. There. Yeah, I've done that. Okay, so I'm going to run it. One, two, three. Okay, I've done something really wrong there. Now, it's put in 3 dogs. Yeah, no problem. Okay, bear with me a minute. I don't have the toString method inside the dog class, so I need to put in a toString method in here. Now, the reason I'm getting name is null, name is null, name is null is because it's calling the toString method from the animal class. Okay, and it's picking the name and the age from the animal class, which is not null. Okay, so I need to do a toString method inside the dog class. So I go public string toString and return name is name, age is plus age. Now there we are. Name is Rex, age is 2. Name is Spot, age is 1. Name is Spot, age is 1. So it's put in 3 dogs. In this particular example, no. Okay? Yeah. Okay? In this particular one, no. But we will be doing it. Okay? So all it's doing at this moment in time is just using the equals method. Okay? So this is using the equals method of the dog class. Okay? If returns true, the dog will not be inserted into list. Okay, so is inserted, is inserted, is inserted, is not inserted. Okay, okay, so dog 1, dog 2, and dog 3, they're all different dogs. Dog 1 is the same dog as dog 4. So dog 4 will not be inserted. Okay? Any questions on that? No. Okay. Now, where am I? Now, contains. Okay, so I'm going to use the set that I've created up here. So what contain will do, it'll return true or false if the list contains a certain object. Okay, so what does it do? Returns a boolean. Returns a boolean true if the collection contains a particular object, false if not. All right, so I'm going to check our list for dog 1. So dog set dot contains dog 1 is going to be true. Okay, I create another dog. And the name is, so this Lassie. The name is Lassie. Okay, so now I'm going to check dog set contains Lassie, which is the name of the object. It's going to return false. Just like if we're checking a list of strings, list. And what does this str list contain? Contains number 1, I think. Str list contains 1. That should return true. Okay, so this one is true. This one is false. This one is true. Okay, so all contains does. Contains is just checking to see does it contain a particular object. Okay, check. No, no, no. Use get for that. Okay. Now, so we're going to concentrate on lists, or probably the rest of today. All right. So this one here. So we have two lists we're going to be using. Now we have array lists, which implements the list interface, and we have something called a linked list, which we won't have done before. Now a linked list also implements queue. All right, to show you what an array list, what the internals of the class looks like. So this is, first of all, this is the list interface. Okay, so we're only really concerned about list references to array list objects for now. Okay, we have list references to an array list object. That means that it also, the super interface of list is collection, and actually I think the super interface of collection is something called iterable. All right, now these are all the classes within Java Standard Edition that implements the list interface. You have abstract list, abstract sequential list, array list, which we will be doing, attribute list, copy and write array list, linked list, which we will be doing. So it's linked lists and array lists we will be doing. There is something called a role list, there is something called a role unresolved list, there's stacks, and there's vectors. All right, the only two we're going to be doing are going to be array lists and linked lists. If you want to learn how to use those yourself, you can in your own time. Knock yourself out. All right, so the first class that we're going to do that you're familiar with is array list. Now array list implements the list interface. Now as list is the sub interface of these two LEDs, list, so array list also implements iterable and collection. Okay, so it implements iterable and collection. Now it also implements something called serializable, which basically allows you to save a class or an object as a zipped file, a jar file. All right, very useful. Clonable, that allows you to use a method called, is it clone2, which is it? Can't remember what it's called. I think it's clone. Okay, a clone is a shallow copy, so it's a copy of all of the variables but not a copy of the actual object. So you produce a clone of a person. If I produce a clone of me, it looks exactly the same as me, but it's a different person, right? That's a shallow copy. A deep copy is you have two references to the one object. That's a deep copy. Okay. So array list, when it implements the list interface, it implements these three guys. It implements list, collection, and iterable. So they're the only ones we care about for now. We don't do serializable until near the end of the course when we're doing databases. All right. Serializable allows us to zip up all of our application in one file. And then that file, all you have to do is download it to any machine and it can run on any machine. So you'll have your GUI all set up, your database all connected up to it. You can save it as one file. All right. Save it as one file with serializable. All you have to do then is you can email it to anyone. Then they can double click on it. Your application runs on any machine. Okay, so serializable, very useful. Yes, serializable is on the exam. Okay, but more importantly, when you're creating an application, serializable, you need to do it. Okay, it allows you to create one file rather than, like, when we're going along here, look at all this. Right, if you didn't have something like serializable, that would mean that in order for someone to install an application on their machine, they'd have to have all these files in this exact order and all that sort of shit. What serializable allows you to do, it basically puts them all into one zipped file. Everything. Now, what we're probably going to be doing is we're not going to be connected to a fully fledged database. We're going to be using something called tinyURL. Now, tinyURL allows you to create a small database that's actually embedded in the middle of your application. So it'll be there. It'll be actually stuck in one of the packages. All right? And you'll just zip it up, and then it'll become something called a jar file. And then anyone who wants to run your application, double click on the jar file, and it'll run. Now you can choose to run it directly from the jar file, or you can use it to install it on your machine. All right. So we are going to be doing serializing, because if you want to develop applications, you have to know how to do serializing. It's actually going to be in here. tinyURL is called. Okay. It's basic, but it works. Right. So you can imagine that you have an application and you want to retrieve some information from a database, right? So it's on a server on the other side of the world. So it connects up to the server, gets all your credentials. But what it might do is it might load your credentials in encrypted format on this. So it stores a small local version of the database on here. So even if you can't connect, you can still use the application because you've got all stored on here. Now, the main reason we're going to be using tinyURL is because it's very portable, and anything you can do basically anything you can do with tinyURL you can with a real MySQL server. All right, so it's just handier because you imagine trying to get passwords, and some days it'll work, and other days it won't work. So that's what we're going to use. Sorry. Oh, we have to do Azure as well. Whenever the flute comes in. If he comes in here, I'm not happen to be here. Tell him Noel wants to talk to you, because he has to put in Azure for us, because he's fluting around the place. That printer's not working since the first week we're here, for Christ's sake. Yes, we are getting Azure. Do his fucking job. Sorry now. So where are we? This guy here. So array list. So what we're concerned here about the array list is these lads for now. So the array list implements all of these interfaces. Now we will be looking into that. Now that's not going to be done until near the end of the course. We'll be doing that. I think we do that as well. I can't remember if we do that. All right. Now, when we're talking about an array list with regards to storing objects on it, these are the ones we care about. Okay. List is a subinterface of collection. Collection. Let's see. Hold on a second. Okay, yeah, so that's the order. So the order is iterable. Now the super interface of that is object. A sub interface of that is collection. A sub interface of that is list. Okay, that's the order. So its object is the superclass, the whole lot of it. Then it's iterable, which is an interface. Then the sub interface of that is collection. The sub interface of that is list. So array list implements iterable because it's the super interface of collection. It implements collection because it's the super interface of list, and array list implements list. Right, so it implements those three. So when we're talking about implementing list, we're talking about the methods of the collection interface. We're also talking about the methods of the iterable interface. Now, iterable interface has methods such as hasNext, .next, .previous. Okay, You need to get familiar with these. We will be doing them. You need to get familiar with these for databases. Those are the commands we use to go through records in a database in Java. Okay, so that's what the ArrayList class looks like. It has a generic type E. So when we create a array list of integers, the add method, for instance, takes add integer arg0. Okay, if you create an array list of type dogs, it's add dog. If you create an array list of type string builder, it's add string builder arg0. Everyone okay with that so far? Yeah, that's why we had to do generics before we did these guys. It was painful, I know. Right, so go back to this slide. So static void ex2. Now you don't have to take down this bit. You can just download it when I have it up there. So see HTTP box, details of all inbuilt Java classes and super interfaces of this list included. Okay. So what is this? This is array list. Now, so list implementation. So list interface or list interface extends collection, and collection extends iterable. So we can have a collection interface to a array list. We can have, sorry, I should say this is the very top. We can have a iterable reference to a array list object. We can have a collection reference to an array list object. We can have a list reference to a array list object. So if you lift reference to an array list object, you have all the methods of collection and you have all the methods of iterable. Do we understand that? Yes? Okay. Now, you can have different, so you can have this kind of an iterable integer, I call it iter list, new array list. Okay, so you only have access to the methods of the iterable interface. Let's have a look at them. You have for each, notify. Notice you don't have add, you don't have add all or any of those. Okay, you do have for each, you do have equals, you do have something called an iterator, which we will be covering after lunch. Okay, so this object only has access to the iterable interface methods. Some of those are, have a look at them, iter, list, dot. So you for each and iterator are the main ones there. say them here, for each and iterator are the main ones from this interface. Okay. We can also have collection reference, collection string. I'm going to go str collection. It's equal to new array list. Go here, import collection. Now, so this object has access to all of the iterable interface methods and the collection interface methods. So we'll have a look at some of the main ones for that. str dot. So we have got add all, contains, is empty, those sort of ones. Okay, so i.e. add all, clear, contains, i.e. add all, clear, contains. Okay, so they are all methods of the collection interface. The last one then, which is the one we're going to be using, list, let's say dog. Go dog list is equal to new array list. Okay, now what's new in this? Dog dot. So I'm trying to see what's new. Get. Okay, get and set and introduce streams as well. Okay, get, set, streams, which are very important. See there, stream. But that's not with the collections as far as I know. Oh, it is. Shit. Alright, so gets and sets is the main ones. Sorry, I should put in here add all, clear, contains, and stream, which is very important as well. We're not going to do those into the next chapter. So this object has access to all of the methods of iterable, collection, and list interface. Okay, i.e. set, get. I don't think collection has them. Just make sure that it hasn't. Yeah, doesn't have get or set. Okay, so lists, so iterable for each an iterator, which we'll be covering this evening. Okay, collection. The main ones of collection are going to be add all, clear, contains, and stream, which we haven't covered yet, but it's the basis for all functional programming. Then you can have a list reference to an array list, so you have access to all of the above plus get and set. Okay, sorry, and then you've got the last one. We're going to go array list. So this is a object reference to an object of the class. So array list string, and we go string array list str r list is equal to new array list. Now that is going to have str. And see, does it have serializable? Hold on. It has clone. That's from the clonable interface. And let me just see. I don't see where the serialize method is. Right, I don't know why that's not there. All right, it should be there, but anyway, so that is an array list reference to an array list object. Now, but if you just want this to be treated as a list, okay? If you just want this object to be treated by a list, you make it a list reference. If you declare it as an array list, it also implements clonable. It also implements serializable. It can be something else. Do you understand what I'm saying? All right. This thing here is just a list, whereas this thing here has additional methods that might not be, they're not directly related to list. For instance, serializable is not directly relatable to being a list. Okay. Cloning is not directly relatable to being a list. Okay. By doing this guy here, it's a list, and all the methods in it are to do with lists. Do you get me? Whereas this guy here, not all the methods are to do with list. Serializable is one. Clonable is another one. Or is it clone? I think it's clone. Let me just see. str dot. It's clone. Okay? That's about creating a shell of copy, which you might necessarily want to do. All right? Particularly if you want to make your array list immutable. Right? So if you want to make your array list immutable, one thing you should never do is that. Because if you do that, you have access to the clone method. And what the clone method does, it creates copies of each one of your records. All right? So that's why you'll see that syntax more often than that. Is that okay? Yeah. Or, yeah, that's it, chat. So then this is a list. Simple as that, right? This is more than a list. Okay, you can serialize it, you can clone it, which really isn't directly related to being a list. Whereas this is a list, that's it, nothing else. Well, right. So if you do that, it makes it harder to make it immutable because you've got the clonable method in it. Right, now, so I'm quickly going to fly through. Oh, we won't fly through anything because it's lunch and I'm starving. So, go to your lunch. Now, we'll fly through a couple of methods of the Rails class that we already know, and then we're going to come on to iterators, which is new. And I'll stop that video.